Hey drillers, I just want to take a quick moment here and we're going to walk through how we do all the parts of the evaporation lab, and I want to show you each individual component. The data is all collected on the computer, so that'll be completely separate from that. You can find that in the click down below where you found this video on Canvas. So let's take a walk over here and we'll take a look at the lab. So here's our first thing. These are all of our different chemicals that we used. So this whole part of this lab was about evaporation, and so we submerged all of these temperature probes, and we'll talk about this in just a moment. We submerged these temperature probes into these different liquids. So our first liquid was methyl alcohol, the second was ethyl alcohol, and then we had isopropyl alcohol. So those were our three alcohols. And then we had acetone, hexane, and heptane. Oftentimes I call the file the anes for those. So if you're watching and looking through your Canvas and you see some of the Excel files or Sheets files, those are called the anes sometimes. All right, so what did we do? First thing we did, unstoppered these, and then all I did was put in this temperature probe inside the liquid here, and then got the filter paper completely saturated with whatever the substance was. So in this case, methyl alcohol. And then we simply just laid it out on the counter right here and we let it evaporate. It's that simple. So not a lot to watch. It's kind of like watching paint dry, to be honest with you. Not much goes on. But what happens? Now then we jump over here to the computer. The computer is connected to the data logger, which is connected to the temperature probe. And then we walk over here and we can see that my temperature right here, temperature 1, now that I've submerged it into that alcohol, is quickly dropping from, it was around 21 before, and now is down to about 13 or so, and it keeps going down from there. So what are we looking for? We're looking for the drop in temperature. That drop in temperature reflects the strength of bond, or I should say attraction, between one molecule to the other. The weaker the attraction, then the colder it's going to get quicker, because it's going to evaporate very quickly. So it's going to be, it's going to evaporate very quickly. So it's going to be pulling that temperature down quick. Why is it pulling the temperature down? That's really the big question, isn't it? So the reason it pulls the temperature down, it's the same reason we have that flat spot in our heating and cooling curve. As we watch it go down here, we can think about that heating and cooling curve. And think about this, right? The reason it was flat is because we were adding heat when we're doing those heating and cooling curves. What if we weren't really adding heat? Like, what if there was no Bunsen burner or stove or anything like that adding the heat? What would happen? Well, it has to get the heat from somewhere because those molecules are evaporating. So where's the heat coming from? Well, it could come from the air, that's true, but the air is kind of a poor conductor of heat like that. But what's a good conductor? Metal. Like the metal temperature probe right there, yeah. So those metal temperature probes are great conductors of heat. So it's pulling heat away from the metal temperature conductor, now metal temperature probe, and therefore that's dropping the temperature. And that's what we're really measuring right here. And so you can see right here, it's gone down to 6.6, continues to go down. Probably you'll get into the 5s before this one kind of bottoms out. We made graphs, so you can see there's graphs still on the screen here. Made graphs, and now your job is to take a look at those graphs. The data has been provided along with them, so click the link and you'll get the whole data file. Find out where the lowest point was. You want to compare. What was the lowest point? What was the middle one? Like which substance kind of was in the middle? Which one was the highest in terms of maybe had the strongest intermolecular forces? And then let's figure out, why was that? Like, why was some of them have a stronger intermolecular force and others have a weaker intermolecular force? So that's what this lab is about. Let's round really quick here and finish this out. So yeah, get this thing done as quick as you can. If you have any questions, see me in tutoring, and yeah, have a great day. See you later. GoPro, stop recording.